Hello everyone! Today I'm excited to share my KaggleX project with you, which is about power consumption analysis in Colombia's non-interconnected zones. A bit about me. I'm a Mechatronics Engineer and an AI specialization student with a strong aspiration to become a machine learning engineer and data scientist. Through this project, I've embarked on a journey across the entire data science project lifecycle, gaining valuable insights into power consumption and grid efficiency. In summary, my project involves conducting a comprehensive power consumption analysis in Colombia's non-interconnected zones, using various data science tools. These tools cover data gathering, cleansing with pandas, effective data visualization with Plotly, data forecasting, and the creation of interactive dashboards using Dash. Now, why the focus on these non-interconnected zones? Well, these are regions in Colombia that don't have access to public electricity from the national grid. Despite covering a significant portion of Colombia and having a population of around 1.9 million people, they face unique challenges like dependence on fossil fuels and a complex geography including jungles, tropical savannas, and the Amazon rainforest. These challenges include isolation, corruption, and armed conflict. The poor electrical conditions in these zones inspired me to take action. I aim to raise awareness about their struggles and create a research report that could help governments prioritize energy projects, forecast future energy consumption, and identify the deficiencies in electrical systems. For this, I've produced a Kaggle notebook that provides valuable insights into telemetry coverage, population density, and the total number of non-interconnected zones. For the analysis, I used a dataset with 3,294 samples containing information about power demand in each zone, sourced from the Colombian government's open data website. Before diving into data analysis, I carefully cleaned the dataset, addressing issues like null values, zero values, and corrupt data. Notably, I discovered that not all the zones had complete data, and in some cases, data was missing due to a lack of energy or malfunctioning measuring instruments. To ensure accuracy, I opted for mean power values over sums. I created interactive visualizations using Plotly to showcase maximum monthly and daily power demand, service hours by location, and the mean active power consumption of all zones over the years. To predict future energy demands, I employed the autoregressive integrated moving average algorithm for one of the zones. The project also delves into renewable energy solutions with a particular focus on solar and wind power. The Solar and Wind Atlas visualizations offer insights into the photovoltaic potential and wind power density in these zones. For practicality, I developed an interactive dashboard using Dash, summarizing the visualizations from the Kaggle notebook. This dashboard allows users to select their location preference, whether by zone, city, or province. In conclusion, the project identifies San Andres Island as a high priority area for energy projects due to its high energy demand. It also highlighted the need for significant improvement in the NIS energy system, including better maintenance and telemetry system coverage. Looking ahead, future versions of this project could match energy needs with renewable power production potential, offering a glimpse of what future investors could achieve while helping to improve electrical systems. While my project focuses on Colombia, the methodology can easily be scaled to other regions worldwide, opening up possibilities for addressing similar challenges globally. Thank you for your attention, and I hope this project inspires you as much as it has inspired me.